Okay, now that we have the launch template ready, let's start setting up an automatic scaling group. I will give it a name like ASGLab. Below, I choose the release template to use. If you have several versions available in the launch template, we can choose the desired version using this drop-down. In my case, my launch template has only one version, so I will select it here. I'll click Next, and here we need to select the VPC and subnet where we would like to launch the EC2 instances. I'm going to select both the demo VPC and the two subnets associated with this VPC. Now, before we move on to the next step, up here, it allows you to override the instance type requirements defined in the launch template. When we created the launch template, we defined the required instance type as v2 micro, but here we have the ability to override it. When we do so, we have two options. You can either provide the instance attributes to match, or you can manually define the required instance types. If we go for the first option, we have the ability to define the required vCPUs and memory. Let's say we need instances that provide at least 2 vCPUs and 2 GB of RAM. And we won't set maximum limits for these either. And based on our selections, we should see matching instance types around here. We can select from the available instance types to use with this auto-scaling group. We also have the option to exclude the selections so that the rest of the elements are automatically included. Also, there are some additional attributes available to select from the drop-down menu here. And you can also use other attributes such as CPU manufacturer, instance generation, local storage interfaces, accelerators, and more. The other option is to manually define the instance types. The first instance type is automatically defined based on the launch template. So, we have the v2 micro, but you also have the option to select additional instance types. If you select multiple instance types, you can define their weight here. In the next section, you can define the instance purchase options. In other words, you can define the division between on-demand and spot instances. Spot instances are EC2 instances available at a lower cost than on-demand instances, but carry a termination risk. The next section allows you to define your allocation strategies for the on-demand percentage and has two options, prioritized or lowest price. When set to prioritized, AWS will launch them in the priority order defined here. When set to lowest price, AWS will launch the lowest price instance type in each availability zone. For now, we will continue with the instance type definition provided in the launch template. In the next stage, we have the possibility to define the load balancer requirements. We have the option of not using a load balancer, attached to and the instances to an existing load balancer, or creating a new load balancer. Since we do not have an existing load balancer, I will click Attach to a new load balancer. I'm going to leave this HTTP application load balancer option checked, because remember I'm launching a web server. I'll give it a name like ALB Lab. And under load balancer schema, I choose internet facing, that is, exposed to the internet. And under default routing, I'll say create a target group and give it a name like TG Lab. This will cause the load balancer to direct requests to the destinations in a target group, which would be in this case, to my EC2 instances. In the next section, we can configure the VPC Lattice integration options. VPC Lattice is a network service that allows you to connect and monitor service-to-service communication across multiple VPCs and accounts. The use case here is that your application developers may be building, testing, and deploying services using multiple accounts or VPCs, making it difficult to monitor them. VPC Lattice makes it easy to connect to them and monitor them, as well as manage network access and traffic flow. For this configuration, we will not be using this service. Then, under Health Checks, EC2 is selected by default. So, when a healthy instance fails a health check, Amazon EC2 auto-scaling automatically terminates it and replaces it with another one. Now, Since we are also creating an elastic load balancer, Amazon EC2 auto-scaling is going to successfully disconnect the bad state instance from the load balancer. It then launches a new instance and connects it to the load balancer. This is all done automatically so that you don't have to manually respond when an instance needs to be replaced. Now, if you enable elastic load balancing health checks, this will allow Amazon EC2 auto-scaling to replace instances when the associated load balancer reports them as unhealthy. So, I can disable ELB because EC2 auto-scaling health check is enough for me. Below, under health check grace period, you specify the time Amazon EC2 auto-scaling waits to check the status of an instance. This allows you to specify a warm-up time and cover the expected startup time of your instance and application. The default value is 300 seconds, but I will set it to 60 seconds. In the next section, we can define additional settings, and the first setting allows you to enable group metrics collection within CloudWatch. This setting allows you to collect metrics to track the history of the auto-scaling group. It includes metrics such as minimum and maximum group size, total number of instances, and more. There is no additional cost to enable them, and this service is provided by CloudWatch, the AWS monitoring service. The next setting is the default instance warm-up. It allows you to specify the instance warm-up time at the auto-scaling group level. This feature is provided by CloudWatch and also helps auto-scaling to make the decision when to scale. When the configuration is not enabled, each instance in the auto-scaling group contributes usage data to the aggregated group metrics as soon as it reaches the in-service state. In-service is the state an instance reaches when it passes status checks and registers with the load balancer. So, since all instances contribute to the group metrics as soon as they go in service, there is a chance that an instance will have high usage at startup and cause the overall group metrics to drift. Enabling this option, then, gives the instance time to warm up. That is, time to stabilize before contributing to the group's usage metrics. This option is useful with dynamic scaling policies that scale based on usage metrics. With this option enabled, dynamic scaling will not be affected by the metrics of individual instances that are not yet handling any traffic and may be experiencing temporary high usage at startup. Therefore, it is recommended to enable this option. Now, since we are in a test scenario, it is not necessary to enable it. I will click Next. And here is where we configure the scaling and group size policies. Here, for example, I can put 2 as the desired instance capacity as well as the minimum capacity, which would be 2. And in maximum capacity, I say 4. So, if we put as an example the t-shirt website, I am saying that only 2 EC2 instances are going to serve my web page. But if the traffic increases and these 2 instances cannot support that load, let it be scaled to a maximum of 4 instances. Now, how do you make that decision? By enabling a scaling policy down here. So, I can use as a metric, for example, the average CPU utilization, which is in this case 50%. If this 50% percentage is exceeded, it's automatically going to add an EC2 instance behind my load balancer. If even then, it keeps increasing that CPU capacity, it goes back to adding another instance until it reaches a capacity of 4 because that's what we configured up here. I'm going to select none for now, so we'll look at this in more detail later. Then we have the instance maintenance policies. Basically, it allows you to control the availability of your auto-scaling group during instance replacement events. This includes health checks, instance renewals, maximum instance lifetime functions, and events that occur automatically to maintain group balance. I will go into detail about this at this time because we will look at it later in upcoming classes. In the next section, we can define the scaling protection. Scaling protection prevents auto-scaling from terminating your EC2 instances. This setting only applies to automatic termination performed by the auto-scaling group. Note that with this setting enabled, instances can still be terminated manually because the setting only applies to automatic termination by the auto-scaling group. I will leave it at that and continue to the next stage. From here, I can configure the notifications. I can choose an SNS topic that I already have created and check the boxes below here for the types of events I want to be notified of. For now, I'll leave it at that and move on. I will not add tags for now and click on Next. Check that everything is okay and then click on Create Autoscaling Group. Already with all this, the autoscaling group will launch the amount of EC2 instances I specified in the desired capacity. Then, let's wait for the configuration to finish, and we will continue in the next lesson.